Good morning. Today onwards, we are going to discuss a new electronic device which is invented in 1948 by J. Bardeen and W. H. Bartain of Bell Telephone Laboratories, USA. And this device is replaced almost all vacuum diodes in the electronic industry. And this is obtained by doping a third element into a crystal diode in such a way that two p-n junctions are formed, and this new device is called a transistor. So from here onwards we are going to discuss about the transistors, which is invented by J. Bardeen and W. H. Brattain of Bell Telephone Laboratories, USA in 1948. So it comes into picture only 72 years before, and it replaced almost all vacuum diodes or vacuum tubes in the industry. Its transistor actually consisting of two p-n junctions formed by sandwiching either a p-type or n-type semiconductor between a pair of opposite types. Accordingly, we can have two types of transistor. If a p-type is sandwiched between two n regions, we can have a npn transistor, and if a n region is sandwiched between two p-type regions, we can have a pnp transistor. So this one is called a npn transistor, and this one is called a pnp transistor. Here we can see that uh, in the npn transistor we can have two pn junctions, one is here and the other is here, and also in the pnp transistor we can have two pn junctions. So here a transistor can be treated as a two diodes connected back to back, and a transistor is have three terminals unlike the diodes. Diodes have only two terminals, a p region and a n region, that is a positive and negative, but a transistor is having three regions. One is called emitter, the other one is called collector, and the middle portion which is thin is called a base. So now let's see the different regions of a transistor. So first region we name it as the emitter. As the name implies, it emits the charge carriers. That means it actually supplies the charge carriers to the circuit containing a transistor. And important thing is that an emitter should be always forward biased. And regarding the doping concentration, the emitter is heavily doped so that it can supply a large quantity of charges to the circuit. And since it is always forward biased, the resistance of this emitter base junction is very small, and this heavily the second region on the other side of the emitter, which actually collects the charge carriers and which is of the same type as that of the emitter, is called a collector region. So collector actually collects the charges supplied by the emitter, and it is always reverse biased. And when we are considering the doping concentration of the collector region, the collector is moderately doped, and usually the collector region is the widest region in the three semiconductor transistor regions. The collector is made wider than the base and emitter, and which is actually moderately doped because it produces a much heat since it is reverse biased. To dissipate the overheat produced due to the reverse biasing, the collector is made very large. Then the third region of the semiconductor transistor is the base, which is the middle portion of a transistor, which is lightly doped always, or you can see during the discussions why it is lightly doped. And it is the thin region when compared to the emitter and collector. So these are the different regions, and while considering, you have seen that a transistor actually consisting of three regions. One is emitter, which is the heavily doped region, and base, which is the lightly doped region, and collector, which is the wider region and which is moderately doped. And emitter should be always forward biased, collector should be always reverse biased. But still we are having two PN junctions, that is, one is the emitter based PN junction and another one is the collector based PN junction. So when we are considering the two junctions, two PN junction, we can have a emitter based PN junction, and remember that this emitter based junction should be forward biased, and this collector base junction, the second PN junction is the collector base junction, which should be reverse biased. So this should be keep in mind always that the emitter base junction should be forward biased and collector base junction should be reverse biased. Since emitter base junction is forward biased, then this PN junction is forward biased, so emitter base junction will have a low resistance because it is forward biased. But this base, a collector base junction, the second PN junction, that is collector base junction, is reverse biased. It will offer very high resistance. So now let's see the action of a diode, transistor. Suppose we are considering the NPN transistor, so we are having a, while drawing the transistors, we will use this collector and emitter also the same width, that is a convention followed. But remember that in actual practice the collector is little bit wider than the emitter in order to dissipate the heat produced due to the reverse biasing. So suppose this is a NPN transistor, and you know that this first one is the emitter, this is the base, and this is the collector. So this PN junction, that is the first PN junction, should be forward biased. Since emitter is N, it should be connected to the negative terminal of the battery in order to ensure the forward biasing, and the positive terminal is connected to the base. and collector should be reverse bias, so this n region should be connected to the positive terminal of the battery, and negative terminal should be connected to the base, so that the collector base junction should be reverse biased. So this is the general connection. And if it is a PNP transistor, we can have this type of arrangement. This emitter is P, base is N, and collector is again P. So this emitter is, since it is a P region, it should be connected to the positive terminal of the battery, and negative terminal is connected to the N region, which is the base, so that the base emitter or emitter base junction is forward biased. And since the collector is P region, so it has to be reverse biased. In order to make it reverse biased, it should be connected to the negative terminal of the battery, and the positive terminal is connected to the base, so that collector base junction is reverse biased. This is the general connections of a transistor. Now, usually, while drawing the electronic circuit, the transistor is represented, every electronic devices are represented by its symbol. You know that we are having a special symbol for diode. For a Zener diode, we will have some modification to that symbol, and here we are introducing a new device which is called the transistor, will also be represented by a certain type of symbol, and which is given like this, a circle, and the three terminals we need here. So we are making one terminal here like this, another terminal is here, and one terminal is an arrow marked at the end, and the third terminal is here. So this arrow marked end represents the emitter. So this is the emitter, this is the collector, and this is the base. So this is the transistor symbol for a NPN transistor. And here the arrow is outward, the arrow mark on the emitter is outward, in order to represent the emitter current is flowing out, which represents the type of the transistor. If arrow is outward, it represents the NPN configuration. Now if you consider the PNP, the symbol for PNP, again we will have the transistor symbol is circle with three terminals. So one will be base, center one will be the base, another one is collector, and another one is the emitter. So to distinguish emitter and collector, we should have an arrow mark on the emitter, and the arrow mark, inward arrow mark, represent it to be a PNP, and the outward arrow mark represents it to be an NPN transistor. So this one represents a PNP transistor. So remember the transistor symbols. The NPN and PNP is distinguished on the direction of the arrow mark on the emitter. The emitter and collector has been distinguished in such a way that there will be an arrow mark on the emitter. The base is always in the middle of the three terminals. Now we have to start with different transistor connections, because in order to discuss the applications of the transistor and all, we need to know the different connections of a transistor, that we will discuss in the next class.